Okay, good morning class. So at this point you guys got your test back that you wrote yesterday. We are busy still with the grade 8 perimeter and area. The reason why we moved it to the grade 9 section is because you are not allowed to use a calculator. Okay. So at this point you have written your class test 1 of term 3. There's another one coming, probably in this week still, on the same topic, which is ratio and proportion, rate, ratio and proportion, as well as area and perimeter. Probably we'll squeeze maybe one question of Pythagoras in here. Okay, so that is what your cycle test will compose of. Okay, rate, ratio and proportion, your perimeter and area, as well as Pythagoras, maybe a Pythagoras question. Okay, so this is a class test. Let's just write here class test 1, term 3. Alright, let's do this. So it says write the following ratio in simplest form. So looking at 1.1, so you've got 12, 30, 12 to 30 is to 48. So what number goes into all? 6. Now some of you say 2 and then 3, that's also no problem, or 3 then 2. But 6 goes into 12 twice, 6 goes into 13 5 times, and 6 goes into 48 8 times. Let's look at 1.2. So 1 over 2 is to 2 over 3. What's my LCM here? 6. So I multiply it by 6 over 1. So 6 over 1 times 1 over 2, and 6 over 1 times 2 over 3. 2 goes into 2 once, 2 goes into 6 thrice. So 3 times 1 is 3 over 1, which is 3. 3 goes into 3 once, 3 goes into 6 twice. 2 times 2 is 4. So 3 is to 4. Okay? Any confusion here? No? The next one says increase 27 grams in the ratio 4 is to 3. So we multiply this. This is 27 multiplied by 4 over 3. Can you see that? That's naturally over 1. So 3 goes into 3 once, 3 goes into 27 9 times. 9 times 4 is 36 over 1, which is 36. So it's 36 grams. As you can see, it's more. Can you see that? If we let's say decrease, then I will say 27 times 3 over 4. Okay. Number 2, 3. Express the following as a rate. Okay. So 248 kilometers divided by 4 hours. So that goes into 62 kilometers per hour. Okay. The 1 mark for 62 and 1 mark per kilometers per hour. The rate itself, okay, the SI unit, the measurement. In 3.2, we are told 689,2 divided by 70 and 1 over 8 liters. So this is kilometers and that is liters. So we put in the calculator 689.2 over, now you see there's a mixed fraction. Are you nuts? I just looked around and I saw you there. You want to kill me? Heart attack? Okay. Right, so that's going to give you 70 and 1 over 8. Not so? 9,83. 9,83 kilometers per liter. That means you say 1 liter you can cover 9.83 kilometers. You understand? Here it says 1 hour, or you can cover 62 kilometers in 1 hour basically. That's basically what that means. Okay. The next one. This is an old tariff table here. No? So this is not the charge currently. It's Even the local cell phone calls is over 2 rand a minute. But this is a very old one, so. Is this direct or indirect?
Direct.
Direct. Why? As the number of minutes increases, the cost increases. Yes, Michael?
Sorry, I wrote direct, but she walked through down.
Why didn't you write the explanation? Okay, so she must get another mark and Jessica, Lisa Kanye the mark that she deserves. You were round of applause, Lisa Kanye. So are you a chocolate now?
Not yet.
Not yet, okay. Now do get full marks. That one mark is the one that's keeping you away from full marks. No. The next test, no? Direct or indirect? Direct. Why? Because as the number of minutes increases, the cost increases. Remember that one thing that we spoke about was direct and indirect, no? But the other one which I thought about this morning, last night when I marked it, the other word that I was looking for was inverse proportion. Okay, so that is the other one where this is the case. Okay. But I think that we're going to do later on. Okay. Yes?
If you didn't say the number of minutes and cost, you just said if y increases then x increases.
It's the same. But you start with x no. As x increases, y. Okay. 4.2, determine the cost of. So, because it's direct, we know that 4,95 divided by 3 is equal to 8,25 divided by 5, which is equal to 9 divided by x, which is equal to y divided by 28.05. So the first one in 4.2 says you must calculate the cost. So in other words, we calculate the x. So what we do is we say that we cross multiply. Take that into account. Or I could have said 4,95 over 3 is equal to 9 over x is the same thing. So I cross multiply. So that is 8.25 times x is 8.25x equals 9 times 5. Or I could have written 45. Divided by 8.25 in order to solve x on both sides. So x is equal to? Sorry? So it's 9 times 5 divided by 8.25. Gives us? No? Is that correct? Can't be correct, so it must be. There has to be more than 8 rand and 25 cents. So is my mistake? So is 8. Okay, 8.25.
So you said, sorry, you didn't inverse 9 over x.
Oh, I see my mistake. Yes, thank you. I see now. My ratio is wrong. Sorry about that. So it's going to be that over that, that over that. So it's 8.25 over 5, which is equal to x over 9. I said 9 over x, no? Which is equal to 8.5 over 1. You? I'm thinking now, what's wrong with me? So it's going to be 8.25 times 9 is equal to 5x. Divided by 5 both sides. So x is equal to 8.25 times 9 divided by 5. There we go. 14.84. Okay? And then I also say that equal to that in order to calculate y for 4.3. The duration if the cost is 28 rand and 5 cents. So it's going to be 8.25 divided by 5 equals 28.05 over 1. Cross multiply, so 8.25 y is equal to 5 times 28.05 divided by 8.25 both sides. So y is equal to 5 times 28,05 divided by 8.25. 17 minutes. Okay? You all understand? The next one is number 5. Determine the perimeter and the area of the following. Perimeter, of course, is going to be the sum around the edges on the outside. So the perimeter of a square is going to be 4 times side, not so? So that's going to be 4 times 12, which is 48 centimeters, not so? Whilst the area is going to be side squared. So side is going to be 12 squared, which is 144 centimeters squared. What type of shape is this? Parallelogram. So the perimeter of the parallelogram is going to be the same like a rectangle. Okay? So it's going to be 2 times 65, sorry, plus 2 times 24. So it's 130 plus 50, which is 180 millimeters. The area of a parallelogram is going to be base times perpendicular. Okay? So base times perpendicular. So what is the base? What's going to be a perpendicular? The 20. Can you see that? So it's going to be, and your base is going to be 65. 65 times 20. So it's 130 millimeters square. Okay. Okay, didn't know this one. Right, nice. Now you know it. All right. Okay. The next one, number 6. Last question. Calculate the area of the shaded part. Round answer off to 1 decimal place. So I'm going to calculate the area here. This is a square minus quarter of a circle. Not so? The areas. How do you calculate the area of a square? Side square minus a quarter. Area of a circle? Half square. So the side is 8 squared minus a quarter pi. The radius is 8 squared. It's going to be 64 minus 8 squared is 64 divided by 4 is 16 pi. And that works out to be 64 minus 16 pi gives us 30,7 centimeters. Alright. Okay, wait. Alright, so that basically brings us to the end of that thing. Then we went on to perimeter and area from the grade 8 textbook. I think we ended off with number 1.18. So I must still do 1.20. You all agree with that? Right, let's take this out here. Right, so what we have here, the question is to calculate the area of the shaded region only. No? Right. So what do you think is going to happen here? The area of the shaded region be the square is diamond. Sparkles. Circle. Circle, circle, circle. 4 quarters makes what? 1. So it's 1 circle actually. Can you all see that, people? It's actually minus the area of a circle. So how do you calculate the area of a square? Side square minus 5 square. So what's the length of the side here? 8 squared minus 5. What's this? What is the length of the radius? 4. From circumference, of center to circumference is 4. Not so? Yes. So that's going to give you 64 minus 4 squared? 16. I think that's the same calculation as the previous on the calculator. So it's going to give you 13 comma 73 meters squared. Okay? Yes. It was fairly simple. Wait, okay. Okay. Let's look at number 2. Okay, I think we must move a bit faster through it because we need to move to the grade 9 section as well. In triangle XYZ. XY is equal to 8. YZ is 5. And the height XE is 4. Calculate the area of triangle. So 2.1, the area of triangle XYZ. XYZ. How do you calculate the area of a triangle? Half base times height, perpendicular. Okay. Here, if this is your base, do we have the perpendicular height? Yes. What is the length of DZ? We don't have the perpendicular height if that is your base. Can you see that, people? Remember the height must stand perpendicular to the base you take in consideration. However, if you had made this is your base, then what would have been your height? 4, which is x. Can you see that, people? So we're going to go with half a base, the area is equal to half base times perpendicular height. So what is my base? 5 times 4, which is 10 centimeters squared. In 2.2, determine the length of DZ. So it's actually the perpendicular height. Can you see that? However, we know what the area of this triangle is. Not so? So the area of this triangle is going to be half my base, which is yx, times my perpendicular height, which is dz. But we know what the area of this diagram is. What's the area of this diagram? 10 is equal to half times yz, sorry, yx, 8 times dz. Can you see that, people? So I divide both sides by half times 8. Half times 8. So dz is equal to 5 over 2, which is 2.5. Okay. So it's 10 over half times 8. 5 over 2, which is 2.5. Okay. Let's go to number 3. A ball with a diameter of 22 millimeters. A ball with a diameter of 28 millimeters. It is rolled from point A to point B. They say that is point A to point B. Yes? Diameter, sorry. I made the radius, no? The diameter is 28. From point A to point B. The length of AB is 43.98 centimeters. So this is in millimeters and that's in centimeters. So what must we do? Convert one of the two. Always convert to the smaller one. So that is equal to how many centimeters in a millimeter? How many millimeters in a centimeter? 10. So I multiply this by 10. So it's 439.8 millimeters. Okay? Calculate how many revolutions. What's revolutions? Complete cycles, 360. No? How many revolutions the ball will make to cover this distance. So if you take the circle into consideration, in other words, when I move the circle will turn so. Okay? So what's going to happen is, as that circle turns, it will cover a distance, not so, and so on and so on. So how many times will that take place for the circle or the ball to move from point A to point B? You guys understand the scenario? He's now shaking your head now. You got the circle. This is your ball. This is now your ball, no? So it's moving from point A to point B. The ball is moving. Can you see it's turning? So if you mark here, no, let's say this is your marking here, no? And this is now at the bottom, of course. So we turn this ball. Can you see it's moving there? So until it reaches again the bottom, that's one revolution. What do you notice? It's also covering a distance. So they want to know how many circles or how many full revolutions will it take from point A to point B. Okay, you guys understand? So does that, if I take one revolution into account, do you think that is the area of the circle or circumference of the circle? Circumference. So that's dealing with the outside of the circle, not so. So in other words, I need to know what one revolution, which is also the circumference or the perimeter of the circle, will cover. Can you see that, people? What coverage will one revolution give us, which is the perimeter of the circle? So how do you calculate the perimeter of the circle? 2 pi r. So it's going to be 2 pi. What's my radius? My radius, if the diameter is 28, the radius is diameter over 2, which is 28 over 2, which is 14 millimeters. Okay? It's going to be 14. So it's 28 pi. Okay? Now 28 pi could also be written as whatever it is. Okay? 28 pi, which is 87.96. If you want, you can write that. But did that tell us how many revolutions it will do? So you say the number of revolutions, or it would simply be the total coverage needed, which is 439.8 millimeters over 28 pi. So you're going to get 439.8 over 28 pi gives us 4,9999, which is actually 5 revolutions. It will take 5 revolutions, full revolutions, for that ball to move from point A to point. You guys understand? Okay. So that is number 3. Let's go to number 4. Number 4, it says, determine the area of the shaded section. Area of the shaded section. Okay. So, how do you calculate the area of the shaded section? It's going to be the rectangle. The area of the rectangle minus the area of a circle. But this rectangle measures what?
So it's a square.
How do you know it's a square?
Because
Okay. If you look at this here, that is a square. How do I know? Because the distance from the diameter there is the same as the diameter there. That's a square. So if you've got a rectangle, can you see that diameter and that diameter will be the same? Not oh, it's a circle, no? But you are guys see. So in other words, the length of this circle, of this rectangle is going to be 100, and the breadth, what's the measurement from the to the? 80. Can you all see that? Jessica? Look here. No? So that is 80. Remember that's 40, 40 and makes 80. Not so? So it's going to measure 100 by 80. And the radius of the circle is what? 40 millimeters. Can you see all is in millimeters? So it's fine. How do you calculate the area of a rectangle? Length times breadth minus the area of a circle per square. So my length is 100 times 80 minus pi. What's my radius? 40 square. So that is going to give us 8,000 minus 1,600 pi. Again, you could have put in that whole story into the calculator there. There's 8,000 minus 1,600 pi. Gives us an answer of 2,973. 2,973, comma 445 millimeters. Okay, you guys understand? Right, let's go to the next one. Number 5. 5 and 6 is together. So 5. Determine the area of the shaded sector. Shaded sector. So, what's going on here? A quarter. No. How much degrees would a quarter of a circle have been? Yes? A third of a quarter? No? Yes? 90 degrees. Not so? Because that's a quarter of a circle. Remember, this is a circle. Half a circle would have been 180 degrees. Not so? Quarter of a circle would be half of that, which is 90 degrees. Is this a quarter of a circle? No. It's less than that. 45 degrees would have been an eighth of a circle. So it was half of a quarter. No? Don't guess. Okay. People, you all agree this is the area of part of a circle. So how do you calculate the area of a circle? Pi r squared. But how much of the circle is this? This represents 60 degrees of how much? 360. If that was 90 degrees, no? If you had a circle, and that was 90, and that was shaded, that would have been 90 degrees of 360, which is, what's 90 over 360? 90 over 90, sorry, over 360. Would have been a quarter. Can you see that? So this is actually 60 of 360. Make sense? So in other words, there's actually a sixth of a circle, okay? So that's going to be pi. What's my radius? 4 squared times 60 over 360. Okay, and that put in the calculator. So that would have given us, I could have worked it out. And again, you can put this in the calculator. No? That is 1 over 6. So it's going to be pi times 16 times 1 over 6. So that is, it goes 3, 8. It's 8 over 3 pi. Okay. Oops. So it's 8 over 3 pi. Which is 8 comma 3 8. 38 centimeters. Otherwise, you could have said pi times 4 squared times 60 over 360. Also gives you 8 over 3 pi, which is 8,3. Make sense, people?
Yes.
Alright. It's a good question, eh? So how much of a circle is that? A sixth of a circle. Or we can say, how many of that sectors can actually fit around here? Then you could have said, okay, the next one would have been at 120 plus 60 would have given you 180, so that's a straight line. And 210, no, 60 would have given you 240, 300, and then 360. So it's 1, 2, 3, 4, 5, 6. Okay, if you wanted to count it that way as well. Okay. But that is fairly simple enough to go 60 over 360, not so?
Yes.
So that is how much of the circle is actually represented there. Let's look at question 6. Question 6. A wheel covers a distance of 660 millimeters in 60 revolutions. Okay? Determine the radius of the wheel. So now this is basically working in the reverse to the sum that we just had with when we spoke about that revolution. So in other words, from point A to point B, that is how much? 660 millimeters, not so? It covers 60 revs or revolutions. Not so? So which means to say, the total distance divided by the total revolution is going to give you the distance of one revolution. Not so? So it's going to be 660 divided by 60 gives us 11. 11 what? No, the revs. There were 60 revolutions. Millimeters. Why? Because that is not going to give you the circumference of the circle.
So don't you say
Per rev, yeah, per revolution. Per one revolution. Okay? So, they want to know, but one revolution is the same as the perimeter of a circle, the circumference of a circle, not so? Which is 2 pi r. So, if one revolution, which is the perimeter, is 2 pi r, what is the perimeter? 11. So 11 is equal to 2 pi r. Remember they wanted your radius. So I divide both sides by 2 pi. That cancels. So r is equal to 11 over 2 pi. Can I give you 1,75 millimeters. 1,75 millimeters. Would be the radius of that circle. Okay. Look at number 7. Question 7. An athletics track consists of a rectangle and two semicircles. The two lengths are 1 meter apart, so that distance from there to there is 1 meter. Okay, Kevin? Looks like you're sleeping. I know you're not. Am I boring today? Boring every day? Why are you sleeping? How does that feel? Now we are told that the two lanes is 1 meter apart. 7.1. Calculate the length of the outside lane. What is the length of the inner lane? 100. So what's the length of the outside? I almost want to say 100 as well. No? Looks the same. So from there to there, it's going to be 100, not so. But remember the question is calculate the length of the outside lane. So this is the inner lane, the total distance of the inner lane, and that's the total distance of the outer. Not so. Alright, so the outside lane, okay, so that is 100, we established that, yes, that's in order. So in other words, it's going to be 100, and this is also 100 here, not so?
Yes.
Right. What is the radius of the inner circle?
30.
30. What's the radius of the outer circle? 31. Why? Because we are told that the lanes are 1 meter apart. So that's 1 meter. Can you see that, people? So the radius of the outer circle, or the outer track, would be 31. So in order to calculate the length of the outside lane, it's simply if I start here, it will be 100 plus a semicircle, which is, how do you calculate the perimeter of a circle? 2 pi r. The perimeter is equal to 2 pi r. And must divide by 2. Why? Semicircle, yes. So it's 2 pi, and what's my radius? 31 divided by 2 plus 100 plus the same story as it happened on the other side. Not so? Which means to say, I could have multiplied this number by 2. So that cancels in any case. So this will be 100 plus 100 is 200 plus 31 times 2 is 62 pi. So that's 200 plus 62 pi. 394,78. Meters. 394,78 meters. Makes sense, people? 7.2. Determine the distance between the starting position of the two athletes so that they can run the same distance. So in other words, determine the distance between the starting point positions. So in other words, we must know how much longer is the outer lane than the inner lane. You all agree the inner lane is shorter.
Yes.
So we must calculate the length of the inner lane. This is the outer, né? Outer lane. So the length of the inner lane is going to be 100 times 2. So it's 100 and 100 here, not so? Plus that semicircle, which is 2 pi r. What's my radius here? 30 divided by 2 times by 2. Not so, because there are two semicircles of the same size. I didn't have to divide by 2 times 5, let's just take it out. So that will be 200 plus 60 pi. So this is the outer lane. So it's 200 plus 60 pi. gives us 388, comma 5. Not so?
Yes.
388.5 meters. So what is the distance, the difference? The difference is going to be 394.78 minus 388.5. Uh, 394.78 minus, that answer give you 6.28. So 6.28 meters. So the person, so if both start here.
Good morning, may I have your attention, please?
Okay.
Emma Brown, can you please report to the office?
If that is the
Emma
point,
Brown to report to the office.
then
Connection.
on the outer lane, that athlete will stand at that point. How many meters apart? 6.28 meters apart. You guys understand?
Yes, sir.
Alright. So, I've given you this for homework already, no?
Yes, sir.
So hopefully we can finish this up. Is this the last question? That is the last question dealing with the perimeter and area. Okay, hopefully we'll finish that up tomorrow. Okay. You will enjoy the rest of your day. Good morning, class.